we're going to use the method of partial fraction to integrate x plus 2 over x squared times x minus 4. Before we do that, let's look at partial fraction decomposition for repeated linear terms. So suppose I have a rational function like x squared plus 6 divided by x cubed times x plus 1 squared times x minus 3 to the 4th power. How do I decompose this using partial fraction decomposition? We have a linear term x that's repeated 3 times, another linear term x plus 1 repeated twice, and the third linear term x minus 3 that's repeated 4 times. The decomposition works like this. We start with x's to the 3rd power, so we're going to need a constant over every power of x from 1 all the way to the end, which is 3. So we're going to need a over x, another constant b over x squared, another constant c over x cubed. So we have to cover all powers of x from 1 until the power that appears in the problem, which is 3. We do the same thing for x plus 1 using different constants, or constants have not been used. So this is d over x plus 1 plus e over x plus 1 squared. And now we're going to need another 4 constants for x minus 3 powers. So we're going to need f over x minus 3 plus g over x minus 3 squared plus h over x minus 3 cubed plus I over x minus 3 to the 4th. That's how decomposition works for repeated linear terms. Let's return to the integral we want to evaluate. The integral is x plus 2 divided by x squared times x minus 4. We notice that the degree of the numerator equals 1 is strictly less than the degree of the denominator. Degree of the denominator is x squared times x, which is 3. We don't need to perform long division. And we see that we have a linear term x that's repeated twice. This is the same as x times x minus 4. So the decomposition will work like this. X plus 2 divided by x squared times x minus 4 can be written as a over x plus b over x squared plus c divided by x minus 4. That's the appropriate decomposition. If you don't include either a or b, you cannot get this problem solved correctly. Multiply both sides by x squared times x minus 4. That leaves x plus 2 on the left. On the right, one of the x's will cancel, so we have ax times x minus 4 plus b times x minus 4 because x squares cancel, plus c times x squared because x minus 4 cancel. Now we carefully have to select various values of x to help us solve for a, b, and c. The values we want to pick that will make as much on the right 0 as possible. X equals 0 will make the a term and the c term 0. On the left we have 2. On the right we have minus 4b. So b is equal to 2 over minus 4, which is minus 1/2. We now select x equal to 4. That will make the a and the b term 0. We have 6 on the left, 16c on the right. C is equal to 6 over 16, which is 3 divided by 8. And now we can't pick any more constants or any more values of x that will make the right-hand side 0. However, since we know b and c, pick an easy value of x, say 1, and we'll be able to find the missing constant a. The left-hand side is 3. On the right, we have minus 3a minus 3b plus c, which is 3 divided by 8. Now b is equal to minus 1/2, so this looks like 3 equals minus 3a plus 3 over 2 plus 3 over 8. Now 3 over 2 is 12 over 8, so this looks like this. 3 equals minus 3a. 12 over 8 and 3 over 8 is 15 divided by 8. And so we have 24 over 8 equals minus 3a plus 15 divided by 8 minus 3a equal to 9 divided by 8, and so a is equal to minus 3 divided by 8. Now let's return to our integral. The integral was x plus 2 divided by x squared times x minus 4. And that was a, which is minus 3 over 8 times 1 over x. So now it's the integral of 1 over x dx. Plus b, b is negative 1/2, so b minus 1/2, the integral of 1 over x squared, plus c, which is 3 over 8 times the integral of 1 over x minus 4. And these are all easy integrals. This is minus 3 over 8 natural log of absolute value of x, minus 1/2 times minus 1 over x, that's the integral of 1 over x squared, plus 3 divided by 8 times the natural log of absolute value of x minus 4. We can simplify this a little bit. We're going to factor out 1/8 from the first and the third term. So we have 1/8. That leaves minus 3 ln absolute value of x plus, and then 1/8 comes out of natural log 3 over 8 natural log of absolute value of x minus 4. That leaves 3 ln absolute value of x minus 4, and then plus 1 over 2x. So in simplified form, this looks like this. It looks like 1 over 8 times 1 natural log of absolute value of x minus 4 cubed divided by x cubed plus 1 over 2x plus c. Or we can write it as 1 over 8, since both x minus 4 and x are raised to the third power. We can write it as natural log of absolute value x minus 4 over x cubed plus 1 over 2x plus c. That's the final answer.